Hey everyone, and welcome back to my channel. So today I am back with another video. So in this video we will try to solve the most asked questions in interview, right? So like, what is the question? The question is, find the order of the circuits intuitively. So without directly going into the Laplace or directly converting this into simple like or Laplace transform, right? And then writing in terms of voltage division. Without doing that, can I compute the order of the circuit? Now at first glance you might say, sir, like these are all first order circuits because like there are only one energy storing element over here, this and this, right? But like wait a second and just watch the video completely, then you will understand it's not always the case. Not always the case. First of all, when they are asking about the order, right, first of all you have to identify where is your input located and where is your output located, where are you taking your output from, and which output are they talking about? Are they talking about voltage output or they talking about current output? So for both of these cases, the order may change. Order of the circuit may change for both of these cases, and also depends on the type of the input. So let's first take this example, right? So I will take this example and you try to solve it by yourself. For here, right, in my case, my voltage and current, I'm talking about both voltage and current. Okay, you compute the order for voltage as well as current for all of this 4 circuits. Okay, and just pause the video, just solve it, then come back to see my solution. So trust me, the method that I will say you, it will be the best method and you will be able to find the order of the circuit just in seconds. So let me first copy this circuit and paste this over here. So I have written something over here. For computing the poles and zeros or the orders of a circuit, right, you have to understand like the type of the input and the location of the input and the output must be known. Okay, type means whether I'm taking voltage as output or current as output. Okay, and location means where is my output present in the capacitor or the resistor, all those things. And then find the effective number of energy storing elements. Also, right, I will here tell you exactly what does energy storing means. I will tell you what does exactly means effective number of independent energy storing elements. How do you identify that they are independent or they are dependent? Okay, so I will tell you the meaning of that as well. So in this case, right, here my voltage is a input source. Voltage is the source this time. So what I will do is I will give this capacitor C, like let's name this as C1, some voltage VC1. Okay, now if I give this some voltage VC1, I can surely say that this voltage is dependent on these two, because if I want to measure my VC2, or you can say VO this time, my VC2 will be simply VI minus VC1. That is my what? That is what my VC2 is. So this capacitor voltage is dependent on this, hence these two capacitors are dependent on each other in terms of voltage. Okay, so if they're dependent, then what I can say, I can definitely say this is a first order circuit for voltage transfer ratio. Okay, for voltage transfer function, this is a first order because I am equating in terms of voltage. I'm taking output as voltage and my source is also, input is also voltage. So for voltage transfer function, I can say that this is a first order circuit. So like I think you have solved this example multiple times before, so like you already know this. Okay, but just for the sake of it, right? So is there any zero over here? There will be a zero. If this goes to infinity, there will be a zero. Okay, but that zero is not at s equals to 0. So I'm not interested in that, although you can compute, right, when my 1 by SC1 will be equals to minus R, that is S equals to minus 1 by RC1, then I will get a 0, right? I'm not interested in that, so I will directly write it in simple this Bode format, right? So this is the standard format that we write. So this is some 0, I don't know, and we have some pole as well. Pole is simply you can compute here, right? This C1 and C2 are in parallel with each other, so it will be C1 plus C plus C 2CR. Okay, pole will be at minus 1 by 2CR, but I'm not interested in that, so I'm just interested in the order. Okay, so this will be some pole tau p. Okay, and there will be some DC gain A tau p. So this will be my transfer function. Okay, but I have already told you that order will be 1 in this case. Okay, now what will be the order when I am taking current as an output? Now when I am taking current as an output, whenever their input is given in voltage and I'm taking current as an output, right, in front of the capacitor, how can I write current? I can write IO will be what? IO equals to, just hold on a second, it will be simply V equals to IR. So V equals to IR, so I equals to V by R. So in our case, Z is what? 1 by Cs. So if Z is 1 by C8, it will be simply VO times C8 Cs. So when I am writing current, right, when I am writing current, if I multiply Cs on both sides, what will happen? This will be converted into current. Okay, so what I can say is that current, right, when I'm computing in terms of current, it adds a 0. Okay, adds a 0. So in the voltage transfer function, okay, so whenever I'm computing for current, right, it will add a 0, it will never add a pole. So always, either at max what can happen is that my current transfer function can either be a zero order circuit, because if I have a pole at s equal to 0, that is possible when this r is not present. When this r is not present, then this 0, like this Cs and S here will get cancelled, and this will become a zero order circuit. You can cross verify as well. This will become a zero order circuit if you remove this R. Okay, but unless and until there is R present and my voltage transfer function is first order, 100% of the cases my current transfer function will also be first order, because I couldn't think of the case where I will have a pole at s equal to 0 with this R present over here. Okay, if this is a first order, it is not possible. First order, it is not possible if R is present over here. So 100% it will always be a first order circuit for current as well. The response will be first order. Response will be exponential. So I can say response will be exponential. Okay, always. Because this just adds a 0, not a pole. Okay, now let's do this same example for second circuit. Let's do this. For second circuit, if I do, this is much more simpler here, right? I just wanted to take a circuit just to explain you one thing, is that previously I was taking the output from capacitor. Now I'm taking it from resistor, right? And for resistor, like this is at first stage, what you do, you give a voltage to this VC1, okay, capacitor. You see that this voltage is related. So VC2 equals to VI minus VC1. So they are related, so they are dependent, their voltages are dependent. So I can say voltage transfer function VO over VI will be first order system. Okay, now as I'm computing in the output across the R, so R doesn't do anything. It doesn't have any frequency component. So I can directly write here IO equals to VO by R. Okay, so it just adds a constant. So nothing will change. This also will be a first order. Okay, so because simply it's a VO by R, right? And anyways, you know, right, whatever the voltage is, we just multiply with respect to a constant, and the current we get, right? The nature of the current is same as that of voltage in case of a resistor. So in case of a resistor, you never need to worry, but for a capacitor or an inductor, you will need to worry. For an inductor, I will show in the next few slides. So this is for voltage input. Now let's go to the current input. Now here interesting things will happen and you will learn something new for sure. Okay, so now let's go for the current input. So if I go for the current input, what will happen is that here I have a current input, right? Current input. How can I say dependency and independency between these capacitors? Should I give a voltage? No, I shouldn't give a voltage. Now, right, I will give a initial current to this capacitor. If I give a initial current to this capacitor, what will happen? I'm giving this initial current IC1. Okay, so can I say the current across this capacitor? Yes, I can say the current across this capacitor. What is the current? Current is IC2 will be II, which is the input current, minus IC2. So current across this capacitor is known to be. So these two capacitors are dependent in terms of current. These two capacitors are dependent in terms of current. So I will write here dependent in terms of current. Okay, dependent in terms of current. Now can you say that the voltage transfer function will be first order? No. If they are dependent in terms of current, then my input is current and my output should also be current, because they are current dependent. So I will say there is only one energy independent energy storing element in terms of current. So I will say that my current transfer function will be first order. Okay, current transfer function will be first order 100%. Okay, as they are current dependent. So my current transfer function will be first order. So just hold on, I will do one thing. This will be now here, right? If I want to compute some 0, right? If I want to compute some 0, so for this case I will compute 0. For others I will just do numeric, like generic names. So here, where is the 0? My current will be 0 here when this provides 0 impedance. So does this ever provide 0 impedance? No. At s equals to infinity, this provides 0 impedance, which is not a real finite 0, not a finite 0. Except that, is there any possibility can I get a 0 over here? No. If this goes to infinity, then only we can get a 0, but no, this doesn't go to infinity. So there is no 0 in this circuit. There is no 0 in this circuit, right? So there is only a pole. There is only a pole. Okay, so the transfer function will be something like this: E upon 1 plus s tau. And what is the tau? If you want to say where is the pole? Pole is at, okay, I can write this as omega p as well. That will be much better. Omega p. Here also, if I write this as omega p, that will be better, right? Omega p and omega z. That will be a better representation. This will be omega z and this will be omega p. So here we have a pole at what? We have a pole at this. C and C will become series because this current I can open circuit, independent energy sources I am making it 0. So this is open circuit. So this C and C are in series. So it is C by 2 and RC. So the pole is where? The pole is at minus 2 by RC. Minus 2 by RC. The pole is at minus 2 by RC. Okay. So do we have a 0? No, we don't have a 0 for it. Okay. That is the first thing. So now let's first see what you can do with the voltage output. If I want to compute in terms of voltage output, what can I do? Okay, so if I want to compute the voltage output, let me just do this. What is my VO? VO of S will be I into V equals to I into R, so it will be IO by CS. Here, what interesting fact happens? The interesting fact is I have a pole at S equal to 0. So if I want to compute the voltage, right? So if I want to compute the output voltage, it adds a pole at S equals to 0. It adds a pole at S equals to 0. So if it adds a pole at S equals to 0, that means the order will increase. Now in just one case the order may remain same if there is a 0 at S equals to 0 for this current transfer function. So if there is 0 at S equals to 0 for this current transfer function, this will get cancelled and it will still remain a first order circuit. Okay, it will still remain a first order circuit. Now is there a 0? So at let's see, at S equals to 0 what is happening? This is going to infinity, this is also going to infinity. So these two are in parallel and a constant current source is connected across them, so current will get divided simply, and current will not be 0 at S equals to 0, and at S equals to infinity as well. If this is S equals to infinity, current will be completely going through here and no current will flow through here, right? So nothing is happening. So we don't have a 0 at S equals to 0 in this case. Okay, we don't have a 0 at S equals to 0 in this case. So there will be no pole 0 cancellation. Order will increase. I will write here unless we have a 0 at S equal to 0 for IO of S by II of S. Okay, unless we have a S equal to 0 at for this transfer function, then there will be pole 0 cancellation. Then there will be pole 0 cancellation. Okay, then there will be positive cancellation and order will remain same, and order will still be first order. Still first order. Now one thing you have to remember for a practical circuit, right? If I am giving a current input and if I am taking the current output as well, then obviously number of poles will always be greater than or equal to number of zeros. Number of zeros can never exceed. But if I am giving input as current source and I am taking output, let's say voltage, then obviously due to the unit conversion, number of zeros can be more. Okay, but I am taking the voltage output, not the current, right? If you take the current output, the number of zeros will always be less than or equals to number of poles. That thing you have to take care of. Okay, so in this case, what is happening? In this case, our response is a second order response. So in this case, we will get our pole will get added because we don't have a zero at s equals to 0. So VO will be a ramp response, and you can understand that as well. Why? Because VO is giving me ramp response. If you observe here carefully, is this reaching steady state ever? This is reaching steady state in terms of current, but in terms of voltage, no. Because in steady state, what is happening? This is giving infinite impedance, this is giving infinite impedance. So current is getting divided, but current is not getting equals to 0. So there is some constant current through both of these capacitors. So if there is some constant current through both of this capacitor, what is IC? IC equal to C dVc by dt. So the rate of change of voltage is always constant. And when does some rate of change becomes constant? When there is a ramp like function, right? Then only it has constant slope. So that's why we are getting a ramp response in terms of voltage. For current, it is a exponential response. So for current, this is a exponential response. So this is a very, very important point that you have to note. Okay, very, very important point. Okay, so now let's come back to another circuit. So we had this 4 circuit, right? So if I have this 4 circuit, so if I again try to understand this, so again I will provide some current through this IC capacitor C1. If I provide some current with this capacitor C1, IC1, so I can write my other currents IC2 equals to IC1 plus not IC1 plus II minus IC1. Then what I can say? I can say that they are dependent in terms of current. So my current transfer function IO of S by II of S, okay, will be first order. And I can also say that there is a 0 at minus 1 by R1 C1, okay, because this short circuits, this goes to 0. And obviously there can be only 1 0 at max, because this is a first order circuit, there can be only 1 0 at max. Okay, so I have a 0 at minus 1 by R1 C1, and I have a pole at what? Pole when these two are in series and these two are in series. So basically C1 parallel with C2 into R1 plus R2. Okay, so I'm not writing that pole, I will just write this arbitrary name, and there is obviously some DC gain. Okay, because at S equal to 0, what is happening? This is proving infinite impedance, this is proving infinite impedance, so they are getting divided. Okay, so now what is happening? Like this, right? This will give me a exponential response. Okay, but what about voltage? Again, my voltage is what? Voltage is IO by C of S. So again, I am adding a pole, and there is no 0 at S equal to 0, so there is no pole 0 cancellation. So my voltage will be again ramp response, which you can cross verify. Okay, which you can cross verify at the steady state, right, in time response. So you can understand that. So voltage is a second order circuit or second order system. Okay, and current is a first order system. Current output, I mean, is a first order, right, and voltage current are their second order. So let's now come to inductor. What happens for inductor? You can pause the video, you use the same method which I told you for inductor as well, just things will change, because for inductor, right, the Laplace transform is SL, not 1 by SC. So that will be just different. Now let's take this most simplest example. This you already know, and everyone knows in the universe who doesn't even have studied transient as well. He also knows this is a first order circuit. Okay, so he or she also knows this is a first order circuit. Now here what is interesting in this case is, if I write in terms of voltage, like there is only one element, so there is only one independent energy storing element. So I know as voltage input is given, I know for 100% my V over Vi, this transfer function will be a first order system. Okay, and how is this? So and what about the current? So if I want to compute the current, right, IO is what? IO is V by SL. So IO is V by SL, VO by SL. So it is VO by SL. And what do I see? It adds a pole, adds a pole at S equals to 0. So it increases the order. It increases the order. So by this, looking at this, people might think, okay, it increases the order. But interesting fact is, we have a 0 at S equal to 0 as well, because at S equal to 0 this is going to be short circuit, so my voltage is also going to 0. Okay, so that's why I have a 0 SL at S equal to 0, like AS by, I am not writing this value of A, this can be any arbitrary number, and obviously 0 can never be more than pole. I have only one 0, and I have a pole as well, where you can compute the pole. It is simply minus R by L. Okay, minus R by L. So but I am not writing the pole, it will be omega p. Okay, it will be omega p. So this is 1 plus S by omega p. Now what is happening, as this is VO by SL, right, this S and this S gets cancelled, and still I get exponential response. That is the most important thing. That is the most important thing. So this will be exponential, and here, right, what is happening? Pole 0 cancellation. At S equals to 0. So obviously this response will also be exponential. Okay, this response will also be exponential. This won't be ramp anymore, because we already know this will be exponential. But just to give you a like intuitive idea why is this the case, right? So let's come back to this circuit, right? This circuit, let's do this. This was the other one. This should be, just don't follow this number. Okay, A B C D E F G H, this should be E F G H. Just hold on, I will just fix this. So in this case, what is happening? Again, I have given a voltage. So if I compute the voltage across this, the voltage is known for this. So they are dependent in terms of voltage. So if I give this inductor some initial voltage VL1, so the voltage across it is known. Okay, voltage across it is known. That is VL2. So if VL2 is known, so I can write my VL2 equals to VI minus VL1. So they are voltage dependent. So my voltage transfer function VO of S upon Vi of S will always be a first order system. In this case, at S equals to 0, this is also going to 0. So both of them are going to 0. So the voltage will get divided, and we won't have a 0 at S equal to 0. That is the most important thing. Why we don't have a 0, I am not explaining it here. I have made multiple videos realizing poles and zeros, and I have made also RL marathon. You can go and watch there. I will not explain all these things here, right? I am mainly interested in the order of the circuit. So this will be somewhat like A plus 1 by 1 plus S by omega Z. Okay, now do we have a 0 in any other case? Yes, right? When this goes to infinity, we can get a 0, because current through this will be 0. This will provide infinite impedance. So that will be the case, but I'm like that will be simply minus R by L again. And where will be the pole? The pole will be simply where it will be this L and L are in parallel, so L by 2, and this, so it is 2 R by L, 2 R by L. So pole will be somewhere, I'm not writing it, 2 R by L. So what about the current? What about the current? If I want to compute the current, right, again what is happening to the current? Current is simply VO of S by SL, right? Again it adds a extra pole. It adds a pole. So if it adds a pole, my response will be ramp, because I don't have a 0 at S equal to 0 for this voltage transfer function, so they won't be cancelled. So response, ramp response. Just hold on. This will be ramp response. Okay, so now this is done. Now like let's cross verify, right? Let's cross verify. What is happening is basically at t equals to infinity, this is also going to steady state, this is also going to steady state. Both of them provide very low impedance, okay, at steady state. So if they are providing low impedance, what is happening? There is always some constant voltage across these two, right? Always some constant voltage that is getting divided between these two because they are of same impedance. Okay, so if it is getting divided, constant voltage. So what is the equation of inductor? VL equals to L di by dt. If voltage is constant, okay, then the slope of current is also constant. And when the slope of current is constant, that means when is the slope constant? When we have a ramp like function, right? Straight line like function. So that's why the response is ramp, and in this case the response is exponential. Okay, and this is first order circuit, first order system, and this is second order system, right? Second order system. Okay, SOS is not that SOS, it's second order system. Okay, just my short form. So let's do it for the other cases also. Now I will blaze through this. So this one is for current, right? This one is for current. Last one I think I will give you as homework because the video will go lengthy. I don't want it to go lengthy. So here, right, what is happening again? Now if I give this some initial current of IL1, okay, what is the current across this? The current across this IL2 equals to II minus IL1. So they are dependent in terms of current. They are dependent in terms of current. So if they are dependent in terms of current, then what I can say? I can say that my transfer function of current, right, it will be first order. It will be first order. So is there a 0? Yes, there is a 0 at s equals to 0. There is a 0 at s equals to 0, right? Why? Because this is giving 0 impedance and this is giving still some finite impedance, so all the current will flow through here. There will be no current here. Okay, and is there a pole? Obviously there is a pole. The pole is at what? Same, right? Minus r by 12. Pole is at minus r by 12. I'm not writing it. Okay, now what about the voltage? What about the voltage of the inductor? So if I want to compute the voltage of the inductor, it will be what? It will be I into SL, I into SL, SL into IO. So here, right, if you observe, I am adding a 0 over here. I'm adding a 0 over here. So response will still be exponential because if I add a 0, right, in time domain, what does it mean? At s equals to 0, in time domain, it means I'm doing the differentiation of this function. Okay, and this is exponential. So differentiation of exponential will be still exponential. Okay, but there will be some impulse instantly. Okay, as there is some s, right, so there will be some impulse. As differentiation of step is impulse also. Like there is that ut also, right? So that will give a ramp as well. That will give a impulse as well. So this is adding a 0. Adding a 0 at s equal to 0. Okay, so this adds a 0 at s equal to 0, but unless and until I got a pole at s equals to 0, right, unless and until I got a pole at s equals to 0, they will not get cancelled and order will change. Order will remain same because this is only adds 0, right? So it doesn't matter to me. This only adds 0, doesn't matter to me. But here you can observe that the order of the numerator, that means the number of zeros is more than the number of poles. But why is this happening? Because I am taking a different output, right? I am taking a voltage output. I am giving current input. I am taking a voltage output. So obviously there is some unit conversion there. So this is what this is. Like you can say this is this is the unit of impedance, right? Unit of impedance. So impedance is getting multiplied, so there is some unit conversion. So if there is some unit conversion, obviously this 0 will get added. Okay, so don't worry about that. That case is still true because my input is current. For current input, right, number of zeros can never be more than number of poles. It will be at max can be equal. Here this can be more. Okay, adding a 0 at s equals 0, but still response is exponential because I'm just adding a 0. Okay, I'm doing nothing, and obviously a impulse initially will come. Okay, initially impulse will come. So for this last one, this I am giving you as homework. You try to say it in the comments below what will happen for this circuit. Okay, and just try to tell where are the zeros present, where are the poles present, and what is the order of for voltage output, what is the order for current output. Okay, all these things you try to say, and I will see you in the next video. Thank you for watching. If you did like the video, do hit the like button, and I will see you in the next video.